All right, everyone. I've got a couple minutes after the top of the hour, so we will go ahead and get started this morning. I want to thank you all for taking the time out of your busy schedules to be with us today here at Fleetguard and to be joining our session titled Engine Oils. And we're going to talk a little bit about lube filtration as well, oil filtration. And before we get started, I'm going to play a quick video to give us a little bit of an introduction to filtration science.
When you're driven to get the job done right, the days are long and the miles are many. You can't accept good enough, and you don't believe in limits. To make something truly better than before, to make it last, you never settle and demand a higher level of precision. Day in and day out, we're on that path, advancing filtration science, developing superior filtration technologies to keep you going, to ensure your performance now and in the future, to protect, to go further, to keep you going. Run cleaner, longer, with the certainty of filtration science.
All right, filtration science, really, it's all about giving our customers superior filtration solutions for unquestionably healthier engines. And so today we're going to talk a little bit about engine lubricants and kind of some backstory to the filtration side of the conversation. So we're going to spend a little bit of time covering the different types of lubricants, categories, a little bit around the American Petroleum Institute, or API, kind of I guess specifications, talk a little bit of stuff around that topic. And then we'll actually get into some lube filtration discussion as well, since those two components obviously interact with each other. And I will just encourage you guys, if you have questions as we're going along through the material, please feel free to drop those either in that Q&A function at the bottom of your Zoom window, or you can drop it into the chat as well. I'll do my best to answer the questions you guys have. I am not the be-all, end-all expert to all of this stuff, so there may be some questions that I don't have an answer for today in our session, but I will be glad to take your question back to our subject matter experts and get an answer for you and reply via email. So please don't hesitate to ask the question. If I don't know, I'll get an answer for you, but I would love to try to field your questions today as we get to the end. So really at the outset of this conversation, I want to talk a little bit about the changes that have occurred to diesel engines over the years. And for many of you guys that have been in this industry for a long time, I know we've got kind of an international audience here today with people in lots of different places around the world. Diesel engines have changed significantly, though, in the last few decades. And obviously, the main driver of that is reducing emissions. And so as governments and entities around the world are looking to reduce our carbon footprint and reduce those greenhouse emissions and NOx particles, there are significant changes that have occurred to diesel engines over the years. But it's not all just strictly driven to emissions. We are interested in serviceability and fuel economy and other improvements to those engines as well. And so that's where OEMs have been able to bring newer and different technologies and improvements and enhancements to these engines to give customers really the best overall experience possible. Now, on the in the food chain of making that possible, there are some requirements that are a part of these changes. One of those, as we think about reducing emissions and better fuel economy and all those kinds of things, would be cleaner diesel fuel. So, many parts of the world have moved on from traditional diesel over to ultra low sulfur diesel. Now we're really, in the last 10 years or so, playing a lot more with biofuels and renewable diesel, which includes hydrogenated vegetable oil. So even a lot of changes on the fuel side of things, which has impacted fuel filtration. We also are seeing improved oil compositions. So the actual formulations for lubricants technologies have greatly improved and greatly changed in the last 10 to 15 years. And we're going to talk about that some today. But all of these things have impacted filtration. So as these changes have occurred to the engine, the fluids that are going in those engines, it certainly means that filtration has had to get better to stay in kind of lockstep with these other technology changes. And so we'll cover a little bit more of that towards the end of today's discussion. But functions of engine oil. So we kind of come to this lubricants sort of overview discussion. And when you think about engine oil or engine lubricant, it's really the lifeblood of a combustion engine. So just like blood flows through our bodies and keeps us alive, if we don't have enough of it or if it's not in the right quality, we're going to have problems with our bodies. And an engine is the same way. We have to have a certain amount of oil designated for that engine, and that oil needs to be in the right chemistry and right composition for that engine to function properly. Now, obviously, engine oil lubricates critical engine components, but your oil does so much more than that. I think sometimes we forget about what all your oil does inside of your engine, but it also helps manage engine temperature. One of the main things that your lube oil does besides lubricate is it's also reducing friction. And because it's reducing friction, it's also helping keep the engine from getting too hot and those critical engine components. So we're managing engine temperature as well. Many of the additives, which we'll talk about in a second, help do a lot of other things, like cleaning the engine. So detergents and different add packs there that help keep the engine clean. That's why oil goes in your engine nice and beautiful and comes out all nasty and black, because it's helping clean the inside of the engine. It's also reducing corrosion. So it's helping keep those metal components from developing rust and corrosion as that engine performs. And oil actually does help maintain compression. It helps seal off certain components. As you think about the interaction between some of those metal components, metal pieces, it actually creates a seal between some of those things. And so much more, right? So the point being that your engine oil, beyond just lubricating, does a lot of other things. It's super important to the life and health and performance of your engine. So when we think about what's in today's engine oils, I just alluded to this a second ago, but really you're looking at kind of two main ingredients. You have a base stock, which this is really the petroleum aspect of your oil. So it's it can either be petroleum based or it can be a synthesized or synthetic blend, but this kind of base stock is roughly 75 to 85% of that kind of finished good product that you would be pouring over into your engine. Now, these base stocks, generally speaking, the American Petroleum Institute breaks these base oils down into 5 groups. So you have group 1, 2, 3, 4, and 5, and essentially they're kind of ratings for the chemical kind of makeup and characteristics, performance characteristics of these different groups. And so basically when an engine or when a lubricant company goes to develop a new blend of oil, engine oil, they're going to pull from one or more of these groups. And so typically your kind of older, lower end technologies are down closer towards 1. As you get up to closer to like the 4 and 5s, that's when you get into like fully synthetic formulations. And so, typically a blender is going to kind of pick and choose some of these different groups to get attributes that they want in that chemical blend. So that's 75 to 85% of your oil. The 15 to 25% of that remaining composition is really tied up in your additives. So just like when you would discuss additives as being a part of an engine coolant or antifreeze, you have additives in your oil as well, in your lubricant as well. And this is really a chemical compound makeup, kind of a formulation that really does all of those other things we talked about. So detergents and dispersants, which we'll talk more about in a few minutes, antioxidants, viscosity modifiers, anti-wear agents, anti-foam, corrosion inhibitors, 4-point depressants, and so on and so forth, right? So all of these other properties of the finished good product that we want, this is where the additive package helps kind of bring that all together. So, kind of like the bullet says at the bottom, this is sort of the secret sauce aspect that ensures the engine is going to keep running the way it's supposed to, keep the engine healthy. So one question, I have when I was kind of coming into learning all of this stuff years ago is, why does engine oil break down? Why do we have to, change engine oil? Why does it degrade, and why do we have to replace it? Well, the short answer is oxidation. So during the combustion process of an engine, those additives will, with heat and all the things that oil and that lubricant experiences, those additives will deplete and wear out, just like additives can wear out in your coolant in your cooling system. And then really that oil is no longer going to be working the way it's supposed to. A good rule of thumb here is that for every 18 degrees Fahrenheit you get above 150 degrees Fahrenheit, the life of that oil or that lubricant is cut in half. And so as that engine temperature gets hotter and hotter and hotter, it's going to have an effect on the life of that lubricant product. Now, one of the things we talked about and in that additive package is a dispersant. So you might wonder, well, what does that mean? Well, as that engine oil oxidizes over time, one of the things that dispersant is designed to do is, through the life of that oil, any contaminants, particles, wear particles, things like that, that we want to, or as that engine's being cleaned from the inside out with those detergents, we want to keep those contaminants and those particles in dispersion, basically, or kind of in suspension, right? We want them to be held floating in that oil so that when it makes its way around to the oil filter will remove them. Now, this combustion process, as those additives start to wear out and the oil doesn't work as it's intended, it's now no longer able to keep all of those things in suspension or in dispersion. And so that's when the oil tends to kind of start to degrade, and it kind of starts to agglomerate or kind of glob together into larger particles. And that's why, if you've ever cracked open an engine that maybe had never had the oil changed, or had never had the oil changed in a long time, well past its oil drain interval, you'll notice that engine kind of turned into a sludge. Well, that would make sense because we're not keeping that oil in the contaminants in dispersion. Everything kind of agglomerates and it kind of starts to solidify a little bit. So really, as you think about the useful life of oil, it's really determined by this oxidation process. That is kind of the limiting factor of oil life. So just a little bit of background here on the evolution of lubricant categories, right? So when we go all the way back to 1940, we started with kind of these commercial categories designated by letters. And again, this is stuff sort of driven by the American Petroleum Institute, or API. You can go read as much about this as you'd like to on api.org. I'd encourage you to go check that out. You can also go check out the Petroleum Quality Institute of America there in the bottom left corner to get more detail here. I'm just giving you a quick overview, but really these categories indicate how the oils have changed over the years. So you'll notice, really, when we started getting into the late 1980s, early 1990s, this is when emissions technologies were really starting to kind of come around from the OEMs, from the federal government. And so these changes to drive lower emissions and be more fuel efficient, all of those types of things, started having an impact on lubricants as well. And so you'll notice kind of the categories in red that are considered obsolete. That just really means these are oils that are not suitable to be used in modern diesel applications. Now, the current categories go all the way back to CH4, which really takes you back to around 1998. Even in terms of composition and formulation, that's pretty old school technology. The most currently used category is what we see there at the very bottom of the screen. We've got CK4 and FA4. These are the two current categories that were introduced in December of 2016, January of 2017. So, we're about 7 years into those two categories. Now, we're going to talk more about those in just a second, but I also wanted to mention here about oil designations. So again, the API they have this service symbol known as the donut. And man, a donut sounds great right now. I wish I had a donut in my hand, but this is the API donut on the screen. And really, this is just a standardized symbol that you will see on lubricant products. As you walk into a retail space, into your local auto parts store, or maybe a heavy duty truck parts store. If you look at legitimate products from legitimate companies like a Shell or Mobil or Castrol or XYZ, insert your brand here, you should see this API service donut. And it's going to indicate two things specifically. Number one, kind of the top half of that donut is the performance level. So these are motor oils or engine oils designated or designed for a particular application. And so when we look at heavy duty trucks and heavy duty diesel applications, again, the current designation we're looking for is that either CK4 or FA4. Those would indicate these are kind of the most current products to be used in the marketplace. Now, the second thing we're going to look for is what's in the middle of the donut, and this is indicating the viscosity grade. So SAE, that stands for the Society of Automotive Engineering. So they're, again, kind of a governing body, sort of like an ISO or API or ASTM, a governing body that manages these types of things, Society of Automotive Engineering. They're going to indicate the viscosity grade. And this is really telling you the measure of an oil's ability to flow at certain temperatures. So depending on what vehicle you have or what piece of equipment you have, that OEM original equipment manufacturer will specify what viscosity grade you should be using in your application. So here we have 10W30, and really what that means is that lower number. So the 10, that's indicating this is the viscosity, or basically the ability to flow of that oil at a lower temperature. So when it's at a lower temperature, it's going to, at a cold start condition, that's how that oil is going to flow as a 10. And when it gets up to that engine gets up to running temperature, it's warm and the engine oil is warm. The number on the right is indicating how that oil or that lubricant is going to perform when it's warmed up. And so those are kind of the two numbers there. I'm really glossing over it at a high level, but these are the kind of things you want to look for in that oil designation on that donut. So again, here's a great example. This is off of just a picture from online, but you can see the donut right there. It designates this is a API CK4 oil. So that's kind of the category or type of oil. And then that viscosity grade or sort of performance metric is shown there in the middle of the donut. So I want to talk just a little bit more about these two oil categories for today, CK4 and FA4. So, if we go back to that chart that had everything going back all the way to 1940, you would see these different kind of letter designations through different years. And the previous category that we were coming out of was CJ4, which was introduced back in 2006. So roughly about every 10 years, we're getting these new oil categories. So we're about 7 years into CK4 and FA4 oils. And as we mentioned, each of these engine platforms that kind of come out every handful of years, there are improvements there. And so the oils tend to improve as well. And it's giving us better fuel economy. And it's giving us lower emissions. And we're seeing much longer oil life. I know from some documentation I was reading, the CK4 and FA4 oils showed about 2 times longer oil life in testing from one of the lubricants manufacturers specifically versus that older CJ4 category. So really what we're talking about here is the chemistry, the makeup, the blending of these oils gives you much better performance and much longer life. And so that's a huge benefit to the end user customers, the fleets, the people that are taking care of equipment, because it means ultimately, they're not having to change oil as often and bring that vehicle in quite as often. You'll also notice there on the right, we talked about oxidation being the limiting factor of oil life. And interestingly, right, CK4 and FA4 oils, when they were introduced, they offered about 60% better resistance to that oxidation process, which causes the oil to break down versus that outgoing CJ4 category. So, fundamentally what we're talking about here is the performance of today's oil categories offer, a lot more performance than what that outgoing category had given people in the marketplace. So just a little bit more detail here around CK4 and FA4. I'm going to cover each of these. I'm just trying to put some real world pictures on the screen so you can get an idea of what you might look for as you pick up, a jug of this stuff at your auto parts store or handling it in your dealership. You'll notice there those API service categories for CK4. It's describing an oil or lubricant that can be used in a diesel engine designed to meet 2017 model year for both on-highway as well as Tier 4 off-highway applications. And you'll notice as well as for previous model year diesel engines. So Todd, your question here, are these diesel oils backwards compatible? CK4 is absolutely backwards compatible. It is designed to be used on current 2017 and newer engines, but you can also run CK4 oils backwards compatible. So that was a very timely question. Thank you for asking. You'll notice also if I make mention of the other bullet point in the bottom in red, it says that these oils, CK4 oils, exceed the performance criteria of CJ4, CI4, CI4 Plus, and even the CH4 engines. So, to your question of backwards compatible, well, those would have been those older categories going back, to the late 90s, somewhere sort of in that time frame. So engine oils that are not considered obsolete, but are not the most current. So you can, and you'll notice that even on the label to the left, about halfway down, it says meets performance requirements of, and it lists even kind of those older categories. So, that's something to pay attention to as you're going and looking at the label of a certain product. It can give you a little bit of an indication of sort of the different types of products in the marketplace. I did want to also mention on FA4 oils. So you'll notice the little donut that I've got the arrow pointing to. FA4 is kind of easy to pick out because it'll actually have FA4 in red. So that little section of the donut will be in red besides the lettering. And these are oils that are described as specifically formulated for use in diesel engine applications, 2017 model years for on-highway engines to meet those greenhouse gas emission standards. You'll notice the other bullet point at the bottom in red, FA4 oils are not interchangeable or backwards compatible with all of those other previous categories we just looked at. So one of the things that was kind of unique about FA4 oils when they came out alongside CK4 was that FA4 really is designed for 2017 and newer heavy-duty diesel engines, for over-the-road heavy-duty diesel engines. They are not designed to go backwards compatible. They're a little bit more of a kind of experimental type of oil. Certainly they're commercially available and viable, but they are really designed for the latest and greatest engines. They are not designed to be backwards compatible. So that would be one thing to pay attention to, Todd, is if you ever run across an FA4, it's for a 2017 and newer diesel engine with really more of the sensitive after treatment exhaust emissions, all of those kinds of things. And if you look at the details there in fine print, it mentions a lot about sulfur levels, parts per million sulfur levels, and the type of equipment, after treatment equipment that would be found on these 2017 and newer engines. So that's kind of the main difference I wanted to point out between a CK4 and an FA4 oil. So I know we're kind of digging into oil a little bit. We're going to talk filtration in just one second, but kind of what's next for heavy duty lubricants and heavy duty engine oils? Well, just as we kind of saw from that chart with the decades going back in time of these oil categories, we're pretty close to being on the precipice of a new engine oil category or categories coming out. So proposed category 12 or PC 12 is slated to hit the marketplace in early 2027. It's hard to believe. It's almost been we're coming up on, that 10-year mark pretty quickly. And again, we're trying to help meet these goals for lower greenhouse gas emissions and those NOx emissions. And so just like we're going to see some engine platform changes from the big OEMs, we're going to see some changes on the lubricant side of things as well. So very likely what is expected to happen is very similar with what happened back in 2017 with CK4 and FA4. There's very likely going to be two categories. One of those will be backwards compatible, and the other one is probably not going to be backwards compatible is the thinking here. And that category that will be a little bit more experimental and not backwards compatible is actually looking at being the first heavy duty oil in kind of that 20, XW20 space. So, we're getting lower, kind of lower and lower and thinner viscosities. And that's just really where things are headed towards and trending towards. And that's, again, if you can help lower that viscosity and make the oil flow more quickly at even cold start temperatures, it just helps ensure that that engine is going to get all that lubricating oil passed around the engine very quickly upon engine startup. So we're going to lubricate everything really well. And it also helps us with fuel economy, because if that oil, the thicker that oil is, the engine's actually having to kind of work a little bit harder to do its job, right? Think about kind of walking on land, walking with maybe water up to your ankles versus walking with water up to your waist. It's harder to kind of trudge through that water up to your waist, where if it's only at your ankles, you can kind of go a little faster. So, that's sort of maybe an analogy and kind of way to think about these thinner and thinner oil viscosities that are coming out. So as you look at trends across the industry, at least here for North America, that's kind of only where I can speak to because that's where I live. There's still a lot of hesitancy out in the marketplace to use these newer viscosity oils, but all of the data really supports these new oil categories, these new oil blends, and the performance that they can unlock. So, we're starting to see more adoption of fleets using CK4 and FA4 oils, but there's, and, kind of getting down to more like 10W30 type oils, but there still is a lot of use of like 15W40 oils in the marketplace. So we're trending, more and more towards thinner, but the marketplace is just kind of slow to adapt. And that's really kind of a little bit of an overview to heavy duty lubricants. And I hope that was insightful. I see a couple questions here, and I'll try to catch those at the end, but I just want to make sure we're giving plenty of time for filtration as well. So thank you for that. Please keep your questions coming. So we talked lubricants. Let's talk lube filters, right? And what's the role of the lube filter? Well, really the job of the lube filter is to remove contaminants from the lube system. We want to get those wear particles out of the oil, and we want to keep that oil as clean as possible through the entire drain interval. So when it's that useful life of the oil has been expended and we're ready to drain it and replace it with new, we want to make sure that lube filter is going to work and do its job all the way through that drain interval. And so as you think about a lube filter, there's really three performance categories you want to be paying attention to. Obviously, we want to be interested in efficiency, and efficiency just is the technical term for how well, or the rate at which particles are removed by the filter from the liquid that it's trying to remove stuff from. So we want high efficiency. That's good. We want to capture stuff at a high level. Number two is capacity, and this is really we're really interested in the amount of contaminant that a filter can hold. So as I mentioned, we want that filter, we need that filter to do its job over the entire drain interval of that oil. Just like on the fuel side of things, we don't have to be changing the filter before it's time to bring that piece of equipment in to do other service works. We want it to last the entire time it can. So how much stuff can it capture and then hold? And then third, and really very importantly for lube filters, is that level of flow restriction. So oil's going to behave a little differently at a low viscosity versus a high viscosity. So it's kind of, think about pouring honey versus pouring water, different levels of viscosity. Your oil is designed to kind of do its job at both of those levels. So whether it's cold or whether it's hot, we need it to do what it's doing. And we want that lube filter to be able to allow that oil to flow through the filter very quickly while still doing these other two things. We want it to flow through quickly so that we can get that lube oil circulating through the engine and lubricating and cleaning and doing all the other things that it needs to do. We don't want the filter to be a hindrance to that lubrication process. So just talking a little bit more specific terms about each of these categories, performance categories of a lube filter, efficiency. When you think about the changes that have come along with high pressure modern fuel systems, we're interested in very, very fine particles all the way down to low single digit microns. So, it's very common that Fleetguard filters are capturing with very high efficiency all the way down to 4 microns in many cases, which is half the size of a human red blood cell. Pretty amazing. On the lube side of things, those systems aren't under quite as much pressure as a high pressure fuel system. And, really the tolerances are not maybe quite as sensitive and fine as a high pressure common rail fuel injector. And so everything we've kind of learned and seen over the years is that particles we want to remove from the lube system tend to kind of be in the 10 to 30 micron range. So, 10 is still very small, but, we're generally looking at larger size particles, wear particles and contaminants that may find their way in that system versus a very sensitive fuel system. So 10 to 30 microns, that's where we want to be very efficient. Once it starts getting down smaller than that, it's just really not quite as much of a concern from what we've seen. I'm going to skip over one ahead to lube filter flow restriction because, again, this has to do with how the filter is designed. And so when you think about the different brands, different types of lube filters on the market, the media or the material inside the filter can vary greatly. Most of your older legacy products in the marketplace, I would say even low-cost filters in the marketplace, even especially a lot of your automotive grade lube filters or oil filters, most of those are going to be using cellulose, which is paper. Paper media, it's been around forever. That's pretty standard, pretty typical for automotive grade filters. If you ever cut one of those open, you'll see it kind of a tan, yellowish looking material. It kind of looks like paper because that's what it is. Still a lot of that out there. Obviously, larger fibers, larger pore sizes, so you don't get as much consistency in the ability to remove very fine particles. And then as you kind of start working your way into more synthetic, man-made materials, that's where we'll start running into things like microglass. Excuse me. And microglass, it's an older technology as well. I'd say still pretty common to a lot of products in the market today. And you can get good efficiency with glass. One of the downsides of using a glass product is, those are chopped fibers, just the same way that cellulose is using chopped fibers. So you're using kind of a glue or resin material to bind those fibers together. You don't get as much consistency in the performance and, physical attributes of that media. So, that's kind of a downside of using glass, but you can get good performance out of it. And then you start moving into the newer technology. So like Stratapore, which is a proprietary melt-blown media that we make, Fleetguard makes in-house. So that's a unique product for us. And then you start getting over into nanofiber materials. So similar to Stratapore, similar to melt blowing, but the fibers are even finer. And I'm talking a lot about fibers and hopefully not putting you to sleep, but the reason for it is because flow restriction. So again, we want that oil to flow through the filter as quickly as possible while still capturing stuff. If we have finer fibers, it's going to be easier for that liquid, for that oil to flow through the filter. If we have big fat fibers like a cellulose or, large fibers and glue and stuff with glass, it becomes more of a barrier for the oil to flow through. So, more of your new stuff, especially on the Fleetguard side of things, we're trying to use a lot more of these melt blown kind of Stratapore fibers, even nanofiber parts. So if you're familiar with a product called like the LF14000 NN, that NN tells you that it's got our NanoNet media. So we're using a lot of these proprietary nanofibers and small fine melt blown fibers. So that's good. That's good for flow restriction. And then I come back lastly to lube filter capacity. And this is really just a great way to think about how much lubricants have changed and how much engines have changed over the years. if we go back to 2010, light duty drain intervals on those Cummins 15-liter engines were at 25,000 miles. We fast forward up to 2017 at the debut of the new oil category. So those CK4 and FA4 engines that we talked about, you'll notice that number jumped significantly, all the way up to 60,000 miles for light duty drain intervals. And as those numbers have kind of, those new grades have kind of, really had time to be proven in the field and get a lot of that data, a lot of that experience from fleets, that number, for Cummins has actually continued to increase up to 75,000 miles for kind of standard use. And if you're using specific oil grades that, each OEM wants you to use. So for Cummins, they really like Valvoline Premium Blue. And so if you're using that Valvoline Premium Blue product, you can go as far as 80,000 miles between drain intervals on a light duty service interval. So those light duty drain intervals. So it really kind of shows you, the filter technology changes alongside the engine, but that lubricant technology makes a huge difference in terms of the life of the oil in those drain intervals. So I wanted to talk quickly about just some different styles of lube filters that are in the marketplace today. There's your traditional spin-on steel shell metal canister type filters. But many and more OEMs are moving towards these cartridge style filters like you see in the bottom left. And, a big reason for that is certainly cost, but it helps capture kind of that aftermarket retail business. So, with a traditional spin-on filter, canister style filter, it's very easy for other companies to go and mimic that same thread size and, offer a product in the marketplace. When it comes to those cartridge designs, they use a pretty intricate locking key and mechanism with that module. And so it makes it a lot tougher for other companies to go and develop something that, you can drop in as a replacement. And the OEMs like that because it kind of helps them capture that aftermarket business, but it also forces, inherently kind of forces the marketplace to use the correct product, which hopefully will help reduce with, engine problems or warranty claims and things along those lines. So a little bit of a trend there. And then kind of the product in the top, kind of that tan product and that product over on the right and kind of the red, there are some instances of applications that use lube centrifuge products, which I didn't really plan on talking about in this presentation today, but kind of uses a different technology kind of method altogether from kind of using a centrifuge type of product to separate contaminant out from oil. Oftentimes we see this in high horsepower applications, so mine sites and things like that. But there are kind of a variety of uses for those technologies if you're not familiar with that or haven't seen that before. So I did want to quickly mention about full flow versus bypass. These are some terms that maybe you've heard before or you're not very familiar with. And so I wanted to just take a minute and cover those as well. Essentially, the names kind of tell you what they do, but a full flow filter is basically seeing all of the flow of oil go through it. So when you think about, a typical oil filter on an engine, generally all of that oil is going to go through that full flow filter. So it's designed to see higher flow rates with a pretty good level of efficiency, right? The type of efficiency that we want. There are some instances of applications out there that will use a bypass filter as well. And so how a bypass filter works is typically it is only seeing a portion of that total flow of oil go through the filter. So oftentimes when you have a bypass, you might have a full flow and a bypass on the same engine, and that full flow is going to see the full flow of oil. That bypass is just going to get kind of a portion of the oil sort of siphoned off to go through it, and it's designed with a really high efficiency. So it's kind of low flow, high efficiency. So it's not going to be able to flow oil very quickly, but the oil that does go through it is kind of getting super cleaned. And so there's been some instances over the years where OEMs have kind of used both of those in trying to keep that oil as clean as possible. So that's full flow versus bypass. What the industry saw a change to over a couple decades ago were combo filters. And this is really something that Fleetguard pioneered, where basically we're getting the benefits of a full flow and a bypass in the same product. And so you see this kind of cutaway version where we've got sort of that stratopore media acting like the full flow portion of that filter. And then we had some cellulose media kind of stacked up in a kind of a grid, kind of cone shape called stack disc bypass. And so it was kind of acting like the bypass portion. And so we were able to put both of those together in the same product and kind of give the customer sort of a 2-for-1, if you want to think of it that way. And so that's something we've been doing for a while. We still sell quite a few products in that space. LF9009 would be a product that kind of fits in that space, if you're familiar with that part number. And then most recently, about I'd say about 8-9 years ago, we came out with a filter called the NanoNet filter for lube, on the lube side of things. So NanoNet was really a media we pioneered for fuel filtration, but we actually kind of saw the benefit of that media technology, and we brought it over to the lube side of things. And effectively, it still works like a combo filter, but if you were to cut one of these open, you wouldn't even be able to tell, because the media is kind of bonded together in a way that, it all kind of looks like the same stuff. But really, about 60% of that media acts like the bypass, and then the other, or the full flow, and then the bypass section with NanoNet kind of super cleans. And so this is kind of the latest, greatest. So if you ever see the LF 14,000, 14,001, 14,002, 14,009, these are all products that kind of design in this space where we're really kind of giving the customer the best of really all technologies. And so we see kind of this evolution. The engines are evolving, the lubricants are evolving, and the lube filters are evolving too. From the outside, they don't really look that different, but the internals to them and the way they're designed definitely evolving to keep pace and really give the benefit of the other changing technologies. And so we see, again, kind of the trends here, right? This is an article from Cummins talking about their Oil Guard program and the ability for customers that are using that Oil Guard program which is basically a sampling program, to extend those oil drain intervals out even farther than that 80,000 miles we talked about. So in the right circumstances, if Cummins has the data, they're looking at the data, and you look like you're in the clear, you might be able to drive your truck 100,000 miles before needing to change the oil, which is frankly just seems insane to me. But that's where we are. That's where the technology is, and it is possible. And so you see a quote there talking about the cost of ownership, fleet maintenance costs and things like that. If we can really take advantage of the technology changes, there's a lot of benefit for the customer, benefit for the businesses operating these machines. And even in the off-highway world, I just was at an event last week and speaking with a representative from Shell, and 500 hours was pretty typical in the off-highway space. He says now it's very typical that customers are going 750 to 1,000 hours between oil drains. So, it's not just the over-the-road trucks. Even in the off-highway space, these lubricant changes are really making a difference for customers and for the businesses out there. I did want to give a couple of additional considerations before I break to some questions. If you're interested in some other kind of ancillary lube filtration products that Fleetguard offers, we do have a couple of ways of staying on top of your lube oil and really understanding how it's performing, when I need to be changing it. Am I changing it too often or too late? Or if there's maybe preventative maintenance issues coming up where you have something else going on in the engine that's causing the oil to degrade, fuel dilution or coolant dilution, those kinds of things. This is a program that you can take advantage of through Fleetguard. It's called our Monitor Fluid Analysis Program. And what Monitor does is, this is a fluid analysis program that we have partnered with Polaris Laboratories. They're an accredited laboratory group that does oil sampling, coolant sampling, and fuel sampling out of their lab locations. They are an international business. And you can order with these Fleetguard part numbers on the row there in red, and actually take oil samples, send this off to through the Monitor program off to Polaris, and in a very quick amount of time you will get a basically a report back from Polaris with the quality and condition of your oil, with also recommendations on what you should be doing, based on what the data says. So there's a few different kits that we offer. I've got a screenshot of our YouTube video there on the right. We actually have a few different YouTube videos that walk through the monitor program and how to take samples and how to get them mailed off and how to access the online portal where you can get the information. I'd encourage you guys, if that's something you're interested in. I know there's many companies that do this type of thing, but if you want a program that is offered through Fleetguard, if you're on the Fleetguard discount program today, that's something you might be able to get access to as well with those parts. So I wanted to make sure you're aware of Monitor. And then the last thing I wanted to mention here in our lubricants and lube filtration discussion today is around Fleetguard Fit. So Fleetguard Fit is an entire product line that we offer today, and Fit stands for Filtration Intelligence Technology. And basically what Fleetguard Fit is a way for you to monitor in real time the performance and life of your engine consumables. So your air filter, your lube filter, your fuel filters, your oil itself, the actual lubricant itself, you have sensors that will basically go on your engine system that collect data, feed that data to a telematics box that basically collects the information. The information is then fed into a online portal that we have where that data is sort of analyzed and crunched. We do the number crunching for you so you don't have to. And then we basically provide recommended actions or actionable insights into how much remaining filter life you have, how much remaining oil life you have. And this is a great way, if you're maintaining, very expensive equipment, if you're somebody that operates mining equipment or heavy off-highway equipment, expensive equipment, or maybe you have a fleet business where you're interested in doing this. It's very, very tailor-made for your situation. So if you only want to monitor oil, or you only want to monitor air or lube filters or fuel filters, you can kind of pick and choose what you want. And it's a data subscription service. So you would have access to an online portal where you can go on and look at the information. This is a really amazing piece of technology. And this is very much where, all heavy duty and whether it's over the road or off highway stuff, this is really where everything's headed. So if you're curious about that, I would encourage you to check fleetguardfit.com. And you can see more information there, kind of use cases, part numbers, ways to kind of apply the technology. And if you got questions on Fleetguard Fit, reach out. But I do mention this because that oil quality sensor is very much a part of this. And if you want to see what your oil is doing in real time, we can absolutely make that happen for you. So a couple of additional considerations there. And that's really all I put together for our time today. If you guys have some other questions on lubricants or lube filtration, I'd be more than happy to try and answer those at this time. I left some time for us here at the end. And if I don't, like I said, if I don't have an answer, I'll go chase an answer for you. So I'm going to take a quick pause here and I'll watch for your questions. So Todd, your other question here about additives dropping out of new oil stored over time, basically like kind of shelf life question here. That's a good question. I think to my understanding, as long as they're not just like sitting out in the direct sunlight or, kind of think about like other fluids you might be storing and keeping track of, probably condition of shelf life is important there, but I don't think additive drop out is something inherent that you're going to see with a lubricant that you maybe would see with, you think about like diesel exhaust fluid sitting outside or coolant sitting outside. I don't think that's the same issue, but I will go and just confirm that. But I don't think that's a problem with lubricants. It's really that oxidation is really kind of more of where you're going to see the additives kind of deplete and wear from the oil itself. Miguel, your question on models for those oil restriction indicators, are you referring to the Fleetguard Fit stuff we just looked at back on this slide? Can you just confirm? I'll watch for that to come back through. Okay, so yeah, if you're interested in any of the part numbers for the Fleetguard Fit product line, like I mentioned, air filters and other things like that. I would encourage you. You can find that from Fleetguard.com. If you want to just put in the FleetguardFit.com, you'll see some literature on there that has those part numbers. I think we've got 3 part numbers today on the air filter indicators, and those are actually pretty awesome little tools as well. I know we didn't really, that wasn't what we were covering today, but I'd encourage you to go check that out. I think you'll find some good info on the Fleetguard Fit, FleetguardFit.com. Yes. And Hugo, will the FA4 oils be used in the new Tier 4 engines in the future? That's a good question. My understanding is that FA4 oil is exclusively meant to be used in over-the-road applications, so like on-highway trucks, big on-highway trucks. I don't think it's really designed to be used in the off-highway space. CK4 oils are going to be what you're going to want to use for those Tier 4 kind of off-highway engines. I'll double check though and just verify that, but that's my understanding. FA4 is really exclusive to on-highway. CK4 is both on and off-highway. Now, when this new oil category comes around in 2027, I'm sure there will be some changes. Those new oils may, both of those may be compatible for on and off-highway. That's kind of to be seen. Really, that's something that the lubricant companies and engine OEMs are kind of working through right now. Good question, though. Here's a good question. Is it a big deal to move into a synthetic oil and back again? I was real close to putting some stuff in here around, kind of mineral-based versus synthetic oils and kind of explaining a little bit there. I'll be honest, I'm still learning about a little bit about some of these topics, but I think it's really helpful because I would assume kind of like coolant, there's probably a lot of misinformation out there and people just maybe don't really know why they're using what they're using. Basically, the difference, when you think about a synthetic versus a mineral oil, a good way to kind of think about it is, kind of the molecules that go into that base stock. And so, a good analogy, a good way to think about it is with mineral oils, you've got a lot of different size molecules. So you might have some, a mixture of big molecules, little molecules, medium-sized molecules, and the way those things all interact together, you just have less uniformity. And so versus a synthetic where essentially it's kind of an engineered oil, an engineered lubricant, and generally when those with those synthetics, all of those molecules are the same size. And because they're the same size, with that oil moving around and lubricating, you have less friction because they're all the same size. They all kind of work cohesively together versus those, variety of big molecules, little molecules, medium-sized molecules. Those tend to create more friction. And so, if you're using a synthetic and then you go back to a mineral oil and then go back to a synthetic, I don't know that inherently it's a big deal, but you're going to get different performance characteristics, performance attributes out of a mineral oil versus a synthetic oil. And then, just kind of reading between the lines there, if you have, if you're not familiar with that stuff, right? So if next time you're at the shop, looking at mineral oils or synthetic oils, you'll see semi-synthetics. And all that means is it's just kind of a mix of a mineral and a synthetic. So it's kind of a something in between, right? So hopefully that gives a little bit of clarity. I don't know that it's a big deal per se for whoever is asking the question. It's really just more about you're going to get kind of different performance out of a mineral versus a synthetic, and that may matter to you. So you probably want to pay attention to it. Good question though. So there's a question here too. I almost missed it. What happens if air gets trapped in the oil? That's a good question. I'll have to go ask and see if there's anything specific there. I mean, as I think about, certainly if air is getting trapped somewhere there, you've got some sort of leak in the system or, something's exposed that probably shouldn't be. I don't know performance wise if it's going to make a create a big concern for you there. That oxidation process is kind of what causes the oil to degrade. So if, heat, kind of that heat and combustion, if you're getting more oil, more air in that system, it's probably not a good thing, but I don't know that it's, going to be some catastrophic issue, but it's probably indicating something's going on where, you shouldn't be getting air in that system like that. I'll ask though, to your question, I'll try to get a better answer for you. Any other questions? I appreciate the questions, guys. Thank you so much. Anybody else? Okay, well, if not, I really want to thank you for your time. If you got your smartphone handy and want to snap a pic of the screen there and just take a quick survey for us, really helps us understand if these sessions are valuable or if we can improve them in any way. So, it's a very short little survey. We'd love to have your feedback. Definitely want to continue doing these once a month, and you can find our next session out on the fleetguard.com website. We're going to be talking about air filtration and kind of best maintenance practices there next month. That's going to be towards the end of April. So in a handful of weeks, we'll be back here kind of the same place, same time. So hope to see you back for that. And if you think this was value added and want to share it with your friends or colleagues, please pass the link along. We'd love to have them attend as well. And other than that, guys, I want to thank you so much for your time and really appreciate it. And if there's any way that I can be a resource for you, please don't hesitate to shoot me an email, and we'd love to try and help you out. Thanks so much. And remember, nothing guards like Fleetguard.